Saludos, ahora sí, estamos grabando. Muy buenas noches, bienvenidos a los Web3 Hackathon 2.0 Seminar Series. Un poquito mouthful, ¿verdad? Pero una excelente ocasión, ¿verdad? Nosotros, Evolving Space, estamos buscando promover lo que son la implementación y el desarrollo de las tecnologías de blockchain. Hoy tenemos al recurso de Kevin Jones, ¿verdad? Él es un developer con mucha experiencia en el campo de desarrollo en Ethereum, y él nos va a estar presentando cómo usar el stack de Scaffold ETH, que básicamente es una herramienta muy útil para sacar aplicaciones descentralizadas, ¿verdad? De una manera, ¿verdad?, eficiente y rápida. Cosas que tengan sus ideas, las puedan implementar. Así que sin más preámbulos, esta grabación que él nos compartió, ¿verdad?, dura alrededor de como 44 minutos. Luego podemos coordinar una sesión con él, ¿verdad?, de seguimiento, para otro taller o algo, aclarar preguntas, dudas que puedan tener. So, nada, los dejo ahora con la grabación que Kevin nos dejó, así que muchas gracias por venir aquí y nada, que le saquen mucho provecho al contenido.
Sí, solo para que tengan un poco de contexto, Kevin sí iba a venir hoy por la noche, pero tuvo un problema y tuvo que salir de viaje, se tuvo que arrancar para el aeropuerto y él tuvo la amabilidad de en el mismo aeropuerto hacernos esta grabación, que era lo que nos iba a presentar hoy a nosotros. Y pues nada, aquí sin más preámbulos les dejo a Kevin Jones, espero que se lo disfruten. Si tienen dudas las pueden poner en el chat y yo se las puedo aclarar. Yo tengo bastante conocimiento también sobre Scaffold ETH. Si se escucha bien, por favor déjenmelo saber rapidito en el chat.
Hello, everybody. Thank you so much for joining. My name is Kevin Jones. Thank you for joining this Web3 2.0 hackathon presented by Evolving Space. My name is Kevin Jones again, and I am a developer advocate for Nginx, and I'm also a developer advocate for Scaffold ETH, which is a toolkit for rapidly prototyping Ethereum-based decentralized applications. And today I'm really excited to talk to you guys about how to get started building on Web3, how to get started building on Ethereum using Scaffold ETH. Coming to you live from San Francisco International Airport. Apologize if there's any background noise, but today I'm hoping to teach you guys some stuff and get you guys started on your journey to build in Web3. So without ado, let me go ahead and share my screen. And let me go ahead and start presenting here. So real quickly, I want to kind of just do a real baseline and just kind of get everyone up to speed. Again, my name is Kevin Jones. I am a technical evangelist and developer advocate for Nginx and for Scaffold ETH. I am also a nonprofit educator at Crypto Mastery. It's a nonprofit that I founded called Blockchain Education Fund. And I am also a photography and filmmaker. If you scan this barcode, this is going to give you all my contact info, all my social media. Please feel free to reach out and let me know if you have any questions or if you just want to connect. I'm also on LinkedIn. So I just want to kind of level set for some people that are kind of new to the industry. And in order to understand really what Web3 is and how to build on it, it's good to understand kind of where the web has kind of come from over the years. And so, I think this is pretty common knowledge, but, the first iteration of the web was really a basic means for broadcasting information, right? It was simple, static files, some JavaScript, but mostly everything was static and things were served over bare metal servers off of disk. And it was really just a means for users to get access to information in HTTP, right? This evolved obviously over the years, and this is kind of where we're at today. We're in this transitionary period where there's lots of different protocols. There's lots of different ways to communicate on the internet. And all of the data and the services and the applications are usually hosted on cloud providers, virtual machines, containers inside of cloud providers that are hosted by large corporations, or possibly people are renting a server in those spaces and serving that themselves. But really, it's a controlled kind of environment. But with this new kind of evolution of the web, obviously things became more dynamic, access to data inside of databases, sharing of that data through APIs where applications can call and interconnect. And then we see this new range of kind of use cases, right, for this, right, where users can interact with each other via social media, get access to more dynamic information that is more geared towards what they're trying to get. And again, there's more protocols and a lot more complexity with this new version of the web. So Web3 is kind of this new idea and way of thinking of building web applications. And more specifically, it's built on kind of these foundations. Number one is decentralization. So everything is deployed in a decentralized way using decentralized protocols or decentralized networks, typically called blockchains, or there are other protocols for file storage and stuff like that as well. But dApps and providers connect to nodes via a JSON RPC endpoint. So users connect to a dApp, which is like a front end, and then that dApp in turn connects to the blockchain, right? And it's a message-based system using messages and transactions. Everything's permissionless, so anyone can interact with the blockchain as long as they have access to generate keys using public key cryptography. And so this sense, it makes it somewhat censorship resistant and immutable, because if you deploy stuff with a specific private and public key pair, essentially no one can stop your application from running on the blockchain. And in this sense, because everything is blockchain based, is based on a public ledger and transparent, everything on the blockchain is visible, right? And there is some kind of Web 2 aspect to Web 3. And this is where you have this concept of providers. Providers are different service providers that provide APIs or SDKs or maybe nodes as a service to get access to the blockchain. And this is something so that you don't have to run your own node, although the true way of being fully decentralized is running your own node. And that way you are completely decentralized. So anyways, let's get started. So how do you build on Web3? Well, front ends are written in usually common frameworks around JavaScript, React, Next.js, Vue.js, and applications are deployed on a decentralized way usually. So something like IPFS, which is the interplanetary file system, or something like Arweave or Filecoin. There's lots of them, but these are where you publish your endpoints in a decentralized way. And it's obviously like static files that you push to this data storage network, and then you get access to those using either an ENS domain name, or maybe you just pointed at DNS to a gateway, like a file storage gateway, which those exist for all of these different platforms, so that you can access these decentralized assets over HTTP. And then for the backend, you write smart contracts. So we're going to be kind of talking about Ethereum mainly here. Obviously, in an Ethereum network, you write these smart contracts, and these smart contracts are essentially code applications that are deployed and stored on the blockchain and replicated across the entire nodes or the entire network. And everything that you execute inside of this is self-executing, so within the confines of the contract. So it removes the need for any kind of intermediary. These nodes can run smart contract transactions, and it really removes the need for any kind of third-party interaction, because you can do peer-to-peer based transactions and messages that you can sign. And these smart contracts also connect as a bank. And usually these languages are written in something like Solidity. There's also Viper. Some people choose to write in Rust. But we're going to be talking about Solidity today. And the front-end applications interact with the smart contract over a JavaScript API, such as Web3.js or Ethers.js. And again, providers provide APIs and SDKs into this network, so that your front end can point to the provider, and the provider can provide access to the blockchain. Again, the most common way to do it is to deploy your own node, but nodes can be very difficult to manage. So a provider is a good way to get entry into the blockchain. And then as you interact with your application or deploy your application onto the public blockchain, the blocks are formed and the application is in a working condition. So this is what Solidity looks like. It's high-level language, object-oriented, statically typed. You can see it's curly braces, very similar to something like JavaScript. In Solidity, there's one important thing to know, is that optimization is key. And that's because anytime you're storing state on the Ethereum virtual machine, you do have to worry about what's called gas. So you do have to pay upfront for any kind of storage or any kind of state change that you do on the Ethereum virtual machine. And it's expensive because all of the nodes inside of the network need to actually take a copy of your application and keep it on there on the disk. And then the same thing goes for state. When you're updating a state, like a variable or some kind of entry in the database or into the blockchain, you're updating that across the entire node cluster. So this can be expensive. So it's very important that you try to optimize your code at all times. What happens is these different languages, in this case Solidity, the source code is compiled down into a lower level bytecode. And in order to read and interpret that bytecode, you need what's called an ABI. And the ABI is essentially an application binary interface that just tells your smart contract how to be read from the actual blockchain. Because when it's compiled down into bytecode, it is unreadable. So Scaffold ETH, what is Scaffold ETH? It is a toolkit that provides everything you need to get started building on Ethereum. It comes with hard hat, it comes with React, it comes with a lot of the framework already plugged in for you. It comes with some ETH hooks, some components, a lot of code that's been custom written. It also comes with a yarn file that makes it easy to orchestrate. And there's tons of content on YouTube. If you want to learn more about Scaffold ETH and go down this kind of journey of learning on Scaffold ETH, a good resource is speedrunethereum.com. When you want to get started with Scaffold ETH, you need to do these three things on your machine. You need Git, obviously, to check out the repository. You need a copy of Node.js to do a lot of the JavaScript stuff. And you need a copy of Yarn Package Manager so that you can utilize the Yarn file that comes with Scaffold ETH. And this makes it easy to orchestrate and manage your IDE or development environment. When you do a Yarn install, it's going to install Hard Hat for you. It's also going to install React. And it's going to start Solidity for you. Well, it's going to install the Solidity requirements, and it's going to give you a Hello World contract that you can start building with that I'm going to show here in a second. So if you're a developer, this is what it looks like to get started. You do a git checkout to check out the repository, or a git clone, depending on what you're doing. There's different branches of Scaffold ETH. So if you're going to pull down the single repository, you're going to do a git clone. If you want to check out a different version, like there's a lot of examples that I'll show in a second, and you can check out a specific branch that has specific kind of standard. And then you do a yarn install. The yarn install is going to install all the dependencies for you. And then you do a yarn chain. That's going to spin up a copy of Hard Hat. Then you do a yarn start. That's going to spin up React. And you do a yarn deploy, and that's going to deploy your smart contract onto the blockchain that you're running in Hard Hat, which is like a local host Ethereum virtual machine. And it's going to update your front end for you as well, and just inject that ABI so that you don't have to worry about that stuff. So let's get started. By the way, if you, like I said before, you need to, if you want to go down this journey of learning on Scaffold ETH, Speedrun Ethereum is a great resource. It's a set of challenges that you go through, and it kind of brings you down into all those different levels of Solidity and deploying a dApp and building the connections between that stuff. And it also teaches you some things around game theory, and it's just a good resource. So check out speedrunethereum.com. If you do get lost and I'm not available, Scaffold ETH developer chat is a great place to start out for support. There's a little over 2,000 developers in there, and they will give you help and assistance and kind of help you along your journey. There's also a great doc site, docs.scaffoldeth.io, which is a great resource as well. So yeah, let's get started. Okay, so let's go ahead and get out of this, and let me just hide this doc real quick because I don't need that. And we can go ahead and get here. Okay, so let me just make sure we got some other stuff closed here. Close out all my other windows that I have open. And also, let's just make sure that we are do not disturb. Okay, cool. So let's get going. So I've tried to load up the site. It's not running. So we're gonna walk through what that looks like. So in my case here, I'm using tmux, which is a terminal multiplexer. I just use it because I can have more than one window open at a time. When you're working with Scaffold ETH, you always have at least 3 windows open. And so the first window is where you're going to check out the repository. I've already gone ahead and done that for us here. So we already have that. And I've also gone ahead and I already did the yarn install as well. So we can see here if we do a yarn install, everything is up to date. So we're all good to go. We're ready to get started. The other 2 windows are also in the same directory. But in this first directory, we're just going to do a yarn chain. That's it. The yarn chain, again, is going to spin up a copy of the blockchain locally and a hardhat. And then over here, we're going to do a yarn start. Okay, yarn start is going to spin up React for you. So just give that a second. We get some weird firewall warnings, but that takes about a minute. So let's go ahead and just let that sit. Let's make sure it's loading. It looks like it is. Okay. And then the last thing is we're going to do a yarn deploy. Okay. So we did a yarn chain to spin up the blockchain, yarn start to spin up React, and a yarn deploy. And we can see that when I did the deploy, we saw some cool interactions here in the console. And this is using what's called hardhat console, which I'm going to get to in a little bit. And we can also see some other contract calls that just happened because my front end just started here. So React is up. So React kind of tried to call the contract, and we see those read calls that are being made from what wallet to what address. And then we can also see that we deployed our contract successfully. So we can see that right here, 0x5f, 0x5f. So those match. So we're making some contract calls. So this is coming from a wallet, which I'll get to in a second. And then we see how long it took. We also see how much gas it took, which is important to kind of start to understand. Gas is in, basically the amount of gas that you need to pay to, make a change to the smart contract. So let's first take a look just real quick at the structure of the file structure of Scaffold ETH, okay? When you first get into Scaffold ETH, there's pretty much 3 folders that you're going to be working in, and it's hardhat, React, and you might go into like the subgraph folder, which is for like the lean API layer for blockchain, which is very interesting. But pretty much these are where you're going to be. Hardhat and React are really the most common places. So when you go to hardhat, this is everything related to hardhat, and more specifically is where your contract is. So we go to your hardhat contracts, your contract, and then here we see that we have a hardhat console that we're importing, version of Solidity, all this cool stuff. But this is our smart contract. It's written in Solidity, and it's got an event defined, it's got a string defined, it's got, you can do what's called a constructor, where you can like deploy something at the start. And then we have a function that allows us to take that variable that we have here and actually update it by taking a new string across and basically passing that into the transaction and essentially making a state change to that variable. So it allows us to update that purpose. And then we log that, and then we also emit an event. So we have an event as well. So let's take a look at what the front end looks like. So if we look here, now we're looking at Scaffold ETH. Again, it is React, so everything is based on React. And when you first log in, you'll see that there's all these tabs here. There's the home directory, there's the debug contracts directory, there's the hints folder, example UI, a copy of the mainnet dice contract, and the subgraph for the graph API for your blockchain data. This first one is really where you kind of build out your app. So if you want to build out a front end and you know React, then you would start programming and kind of writing in your UI here. You can think of it like an app within Scaffold ETH, right? And that is available inside of the React app, and then under source, and then under views. So the main app file is app.jsx, and then these are all imported as well. So the home directory is where your main kind of app is, and that's your starting point. But what's the coolest part of Scaffold ETH is actually this debug contracts folder. It takes a copy of the contract and it builds all of the fields that you need so that you can start kind of testing your contract. So let's go ahead and do that. So first, let's try to update the purpose to Web3 hackathon. This, boom, and I hit send. Well, it's going to tell me that I don't have any money in my account, because when you first start out, you have what this called a burner wallet. And so it's empty. It's kind of like a starting wallet, right? And we can see it here. This is the address. We can click it, see what that address is. We can also copy the address. And if we look at our console, it actually matches right here. It matches that as well, right? And we can see when I tried to make a transaction, it told me the error here inside the console as well, which is really useful. So now let's get some funds from the faucet. All we gotta do is click that button, we get some funds, and they're actually sent from hardhat. So we got about $12 in ETH. We click it, that's 0.01 ETH. It shows us how much ETH it is. It shows us how much US dollar it is currently at this time. And that's all coming from the gas station here. So the current price of Ethereum is $1,200. And the gas price average is about 53 Gwei. And then we can also see that the wallet here, we can access it and we can export the private key if we want to. We can also import a private key. We can send funds around using this, kind of think of it like a wallet, like a real crypto wallet. You can send funds, or we can connect to MetaMask and wallet connect and different kind of stuff as well. We're not going to do that. We're just going to use these burner wallets, which are great because they're inside the browser. So if I open a new localhost 3000, I'll get the same wallet here, right? So it's inside the browser. But if I open up an incognito window and go to localhost 3000, I'm going to get a completely different wallet and a completely different identity, right? So this is the little green blocky dude. This is the purple blocky dude. And so what that allows me to really do is start kind of testing my assumptions. I can start doing some things that are interesting with smart contracts and see how that experience is different for different kinds of users. So let's try to do that right now. Well, first let's actually, we have funds, let's try to change it. Okay, it was successful because now we were able to pay the gas, right? So we paid a little gas, we updated the state, and now it's changed, right? Let's start making some changes to our smart contract. So let's go back into Atom and let's close out this for right now. We're not going to mess with React right now. We're just going to go to your contract and we're going to make some changes. So first of all, what I'd like to do is show you how you do importing. So the first thing you learn with Solidity is you either import an existing smart contract, and it's a lot of times it's better to import one that is written by a trusted source. And so one of those trusted sources is OpenZeppelin. So you can see here there's an example of how we can import OpenZeppelin. And then what we can do is we can inherit the smart contract that we import. Just like we imported Hardhat console to do the logging over here, we're going to import Ownable, which is a access control contract. And then we're going to do is ownable like this. Okay. So that your contract is ownable. And then we're going to come over here and we're going to make this particular function set purpose only available to the owner. So unless you're the owner of the smart contract, you cannot make that change. Okay. So let's save that, right? And then let's go ahead and redeploy. Now, if we want to redeploy, we can force a redeploy by doing a reset. If you ever want to force a new contract, you just do yarn deploy -- reset, and that will force a new deploy. So our deploy was successful. So if we come back to our app, now we'll see that we have some new stuff here. We have a new function, two new functions. One is called transfer ownership, which allows us to transfer the ownership of the smart contract. One is to renounce it, which is if you want to make an application live forever and throw away and burn kind of the access to it from the public and private key, then you can renounce it, which is a cool way to show that your application is completely trustworthy and can store and manage funds itself. But we'll see here that we have this new owner variable, but it does not match our particular private key and public key pair or address, I should say. So it's different. We did get a new contract and we could do another deploy and see what that would look like. But you'll see that if I do a reset, then we get a new contract. But we still have this weird address as the owner. And that's because Hardhat specifically uses the first account in its list to act as a deployer, okay? So what we need to do is just take control of this contract. So the second thing you'll learn with deploying on Scaffold ETH is you're going to want to be able to gain access to the contract. And the way to do that is to call this function here called transfer ownership at the time of deploy. So what we're going to do is come into our deploy your contract JavaScript, which is basically how your contract is deployed. And we can see here that we get the deployer, which is the deployer address. We use that deployer to deploy the contract. And it's going to grab the first address from the named accounts on Hardhat. And then we can also pass variables to the constructor here if we wanted to, like if we wanted to pass like a name of like an NFT or something like that, or maybe you want to do like, I don't know, set a certain amount of tokens. That's good to know that you can pass those arguments to the constructor there, but we're not going to mess with that, but it's good to know. And then you'll see here there's an example already written that allows us to do this transfer of ownership. So let's paste it here and let's do that. So because we're getting an instance of our contract here using ethers JS, we can then take that and call that transfer ownership function and pass the address. So let's grab this address here and then let's paste it here. And then let's go ahead and save that. And then let's do another deploy, force it with a reset. Okay, so now what we did is we deployed the contract and then we transferred it. So now it matches. So now we've got access to this contract. So if I come over here and I want to change the purpose to SFO, I'm an SFO, hit send, it's going to let me. But if I come over here to this purple blocky guy, go to debug contracts, get some funds from the faucet for this other identity, come over here and change it to YYZ and hit send. Oh, the ownable caller is not the owner. So we've been able to set up some cool access control, which is very interesting, right? But let's do something a little bit more interesting, because no one's going to make, I mean, this particular use case would not be interesting for only one person to change the purpose, unless it was like, I don't know, maybe they're updating their social media tagline or something, I don't know. But let's do something more interesting. So let's go into Atom. We can get out of this now. And instead of requiring this to be only owner, we'll still import ownable and we'll still inherit the contract here so that we get access to the functions. But what we will do is we will require that people, if they want to call this function, instead of just being the owner, let's make them pay a fee, right? So let's make a unsigned integer public and let's call it price. And let's make it 0.001 ether. Now you can see here that it tells you how much ether is equal to way here in Atom, because I have like a linter installed that allows me to see that. But you could put way here if you wanted to. Way is obviously the smallest denomination of ether, but because we're using hard hat here and we can actually get access to ethers.js. So let's do that. Let's do 0.001 ether. And then let's make it so we already made the contract payable so that we can pass in some value. But what we need to do now is a require statement. This is also another kind of first thing you learn, is that you might need to require that a certain case is in the transaction. So what we're going to do is say, hey, we're going to require that the value that's being passed, the message value, so if someone's sending a message or a transaction to this function, we get access to the global variables of them. So we get access to their address, which is address or message.sender. We also get access to the value that they're passing in that transaction. And we're going to say, no, not enough money. I think it's all right, like this. Okay. So now we can say, all right, well, this particular transaction needs to have a value of this much price, otherwise not enough money. So let's save that. And let's go ahead and reset and deploy. Okay. So now this function's available to anyone to call, but in order to call it, we need to pass across this price. So here's the amount of the way. And so if you, the other thing you'll learn about, when you're transacting on Ethereum, you need to pass in this way, the lowest denominational value. So instead of, let's do, I don't know, Kevin is cool, something like that. And we want to pass in 0.001 ether. And you'll see that there's this cool green button here, which is built into the UI. And this does the math for you, which is takes the value, multiplies it by 10 to the 18th power, which is how you calculate ether to way. So we can just click that, and it's going to give us this kind of math for us. We could have also just copied and pasted this right here, but let's just assume that we didn't know what the price was. So we can hit send, and boom, now it let me. So now it gave me access to make an update. I can also do the update over here. I can say Kevin is not full, and 0.001 ether like this, and send. And now you can see what happens here is our smart contract starts to get value. So now we have the smart contract that's acting as a bank. But the bad part is now this is actually a black hole, because we have no way to actually take the funds out of the smart contract, right? So the next thing you would do is, well, let's make a withdraw function. You've built this smart contract, and now you've kind of built some cool functionality into it, and you've been able to start taking value to do something on the. And so the next step would be, all right, well, let's allow someone to withdraw those funds. So let's do a function, withdraw, and which I spelled withdraw wrong, but so and then we'll just do, like this. We'll make it public And then what we'll do is we'll require, actually, let's not require anything right now. Let's just write the language that we need to for the actual thing. So what we want to do is set a Boolean called success if we call this, otherwise we won't. And then we'll say, all right, message.sender.call. So when you want to do a data, or I should say a value call from the contract, or a withdraw from the contract, you should do a call. And so we do a call, and then we pass the value in a kind of like a JSON string here, and we'll do address of this smart contract. So this is this smart contract's balance, like that. And then I think we need to close this off like this and like that. So this is going to say, okay, let's withdraw the funds, but the message.sender is going to do a call to the contract, and the value of that call should be equal to the balance inside this contract. So it's basically like a drain. But let's add only owner here, like this. And so what this is going to do is set up that access control for the withdraw that we set up earlier. Let's go ahead and save it, and let's go ahead and reset. So we'll reset our and deploy our contract. Looks like everything is good. And boom, we're good to go. Okay, so now we have this function, so we can go ahead and let's come over to this blocky guy, purple blocky guy, and let's change the value to I am so cool, and then send. And boom, we were able to put some money in the contract. But now, if I use this function and I'm over here and I want to withdraw that $1.21, I could try to call that, which is, you can't see it, but it's right here on the bottom. Let me see if I can move this. Withdraw right there. And we're going to try to withdraw that, and send is going to say, nope, not the owner. So we have this cool function. But now if I come over to this guy, which is the owner, I have $1.21 in the contract, I should be able to withdraw. And boom, I was able to get those funds out of the contract and into my wallet. So now we've set up this cool access control. But one more thing. Let's say we want to have a more dynamic environment for this. With one small change, what we can do is require that the price is equal to price times 101 divided by 100, and hit send or save, and then redeploy. And make sure it's successful, which it was. And now what we can do is, let's say we update the purpose to SFO and pass in this. Let's copy the way it needs to be in and send. Now we can see that our price has been updated. So with one little small addition to that smart contract, we're able to start making this kind of adjusted price, where the price gets increased by 1% every time someone calls this function. So the more people that call it, the more expensive it's going to get. We could even do something even more crazy. I don't know, let's do it price times 2, like that. And let's redeploy. So we could come over here and say, all right, Kevin is cool, like this, send. Now it's double expensive, so let's do it again. Kevin is not cool, send, boom. So wow, this is getting really expensive. Like that, boom, and we need to change that. So you can see how you're able to make these kind of interesting smart contracts that start acting as a bank. And now this smart contract has $8.47, right? And so you can figure out cool ways to make an economic kind of value to your smart contract and to your hackathon project using all of these kind of core principles, okay? I do want to mention one thing. So if you are deploying to a test net, so everything we've been doing so far has been local host. You might at some point say, all right, well, let's deploy to Goerli, which is the test network for Ethereum. So what we could do is we can do a yarn run generate, okay? Yarn run generate is basically going to generate a mnemonic inside of the hard hat directory. So we can go over here to our directory and we can see the mnemonics here. So we just generated one right now. I'm not going to click on it because it actually has could have funds, which I'm going to add some funds here in a second. And then what you can do is you can fund that address. So here's the address right here. So you could do that from like a wallet. What I like to do is I have a copy of what's called a Punk wallet on my phone, and I just have like a link to it. And I have some like testnet funds on there. So what I can do is I can do a Yarn account. So I've generated an account. Now I want to see that account. And I can use my Punk wallet here, which has some Goerli funds, hit account. It's going to bring up a QR code for me. I can just scan that really easily. Oh. For some reason the scanner is not working. Let's try it one more time. There it goes. Okay, so now I could send some funds to this address. So let's do that. So 0.01 Ether should be enough. 0.01 ETH send. Oh, let me make sure I'm on the right network. I was on mainnet. Let's go to I'm having UI issues. All right, here we go. Goerli, and let's try it one more time. 0.01 Ether. Okay, so I just sent that now. So it might take a second. The transaction is going. We'll give that a second, okay? So what did I do? I took some funds from my wallet that I have on here, which has a lot of testnet funds, and I just sent those to this deployer address. There it goes. It went by successfully. So now I can run Yarn account again, and it's actually going to check my balances for me. And so when it gets to Goerli, we should see that I have, there it is, balance 0.01 ETH right here. So we should be good. Okay, so at this point, let's go ahead and let's deploy our smart contract to a testnet, because we've deployed it on localhost. So we can do a yarn deploy -- network, and we can do Goerli like this. So what that's going to do is going to take our smart contract. It's going to use those funds. Oh, it might not have enough money. Unexpected error. Yeah, I'm not sure. Well, it could be that I didn't send enough funds, or just maybe they haven't updated yet. But yeah, so I can do it. Let me just send a little bit more. So let's do 0.0, I don't know, 5. Maybe that was not enough. Sorry, this is the thing with testnets is you have to wait a little longer, right? Because they're a little slower. When you're doing everything localhost, it's nice and fast. So let's try it again. Okay, it looks like my it was successful almost. Takes about 15 seconds or so for a transaction to go through. Sometimes it can take a little longer, depending on the amount of people on the network. The testnet's a smaller network than the Ethereum mainnet. There it goes. So now it's successful. So we do a Yarn account. Now we should have 0.06. There we go. Now let's try a Yarn deploy again. -- network Goerli. So again, we're going to take our contract and we're going to move it into Goerli. There it goes. So now it was successful. We had enough money on there. So now our transaction is processing. Again, takes a little longer. And we'll let that kind of do its thing just for a second. But I want to show you how you update your front end. So obviously, if you've deployed your contract to a back end, at some point you need to update your front end before you're going to push that update out. So we come into React and we come into our app JSX file and we go to the top. There's a networks variable, initial network that gets defined. There we go. Our smart contract deployed. It took 32 seconds and it took 607,000 gas to deploy. So let's update our app JSX here to point to Goerli as well. All we have to do is put Goerli like that. Hit save. And now we can refresh our app here and refresh, and we'll get a copy of, we'll get access to the contract on Goerli. So now we can interact with them in Goerli. Now I don't have any funds in this wallet with Goerli, but I might have with MetaMask. So let's try. Switch to Goerli. Switch network, which I should have a lot of funds here. Yeah, I've got 91 ETH on this contract, which I wish it was mainnet, but all right, so here we go. I got some funds here. So now I can change the purpose to Kevin Jones just deployed to Goerli and 0.001. Pass that, hit send. Now we got to sign the transaction. We were dealing with burner wallets, which one of the benefits of burner wallets is you don't have to sign transactions or deal with nonsense. It takes care of that stuff under the hood. So we can hit confirm. And so now our transaction started. There we go. And while that's doing that, I want to take a copy of our React code, and I want to do a yarn build. Yarn build is going to optimize the build to be deployed in a static asset way. So we'll just let that sit. Okay, cool. So let's see if the transaction went through. Let's go ahead and refresh here. Refresh, there it goes. So we can see our price doubled, and Kevin Jones just deployed to Go Early. So now this smart contract has $1.21. So if I come over here, oh, actually, so I don't have access to this particular thing, but if I log out now, log out, and I have no funds in this burner wallet, but guess what? Now I can withdraw. So let's do a withdraw. Oh, I don't have any gas. So we can send myself some gas. Let me do this. Let me connect to MetaMask. Let me come over here. Oh, sorry. Let me come over here to here, and then let's send some funds here. Let's do 0.0, let's do 0.1 and send some ETH there. We got to sign that transaction. Transaction started. So basically, what I want to do is I'm just sending myself a little gas to my burner wallet, which is the owner, right? You might want to maybe in the future, like if you're going to deploy to a testnet, maybe send the contract to your MetaMask address before you're about to publish it. That might be a good best practice because then you control the private keys and stuff like that, or the private key. Okay, so the transaction is almost done. It should be done here in a second. Let's go ahead and log out and see if it came through yet. Let me do a refresh. Really can be a little slow, so. So it actually might be good. I might be able to do it now. Let's try withdraw. No. Yeah, so it's just running a little slow. We could also do this. I could just go here and then I could hit scan. And oh yeah, so I could scan. Oh, that's not the other way. Sorry, that's not what I wanted to do. I wanted to show the barcode, so receive. We could also do that. Like I can come over here to my Punk wallet and I can just scan from here. So if you have like a wallet on your phone, it's just a little easier. So you don't have to connect MetaMask. And then we can do 0.01 ETH send. Oh, that's a really cool Punk wallet. Okay, cool. So that started. Okay. Give it a second. There we go. It succeeded. Okay, so now we got $12 here. So now I should be able to get these funds. So there's $1.21 in the contract. Now I can hit withdraw. There we go. I was able to pull. Well, that's about to pull. Transaction started. There's $1.21 in the contract. And then we're going to take those funds out, and we're going to put those into our wallet. So we had $12.10 in our wallet. We might need to just do a refresh real quick. There we go. Oh, the price of ETH dropped a lot right now. But yeah, so I was able to withdraw those funds to this wallet. So yeah, so overall, I think you kind of get the idea here of how do you deploy. There's one more thing I just want to show, and that's after you've created your build on your front end, which is here running localhost. The next thing is you're going to want to ship that to a public endpoint. So to do that, we can do a yarn surge. We can also do yarn IPFS. I'm going to use yarn surge because surge is a great like kind of static file host service, and it's just getting a little easier. You don't have to worry about like IPFS gateways and stuff like that. So we're going to do a yarn surge. Ideally, in a fully decentralized way, you would use yarn IPFS. But let's rename this to, I don't know, Kevin is here. Actually, let's do like this. Okay, cool. So I took this build and I'm pushing all the static assets to Surge. If you didn't have an account with Surge, it would prompt you to create a username and password here, but I already had one. So now we should be able to go here. Any of you guys can go here actually, and we can go to that URL. So let's close this. Let's go File, New Window, and let's go to this address here instead. There we go. So now we have a copy of our app living completely decentralized. But if you just noticed, I closed out Chrome and I lost the private key. So technically this application will live forever. There's no way it can be stopped. And we can see here that we have our contract. We have the state still there. Kevin Jones just deployed to go early. We have the price. It's being doubled every time. There's no money in the contract. And it's pretty much a black hole contract at this point. Okay, so I'm going to go ahead and stop sharing my screen here. What I would like to do is just say that if you need more help and you're stuck in any way, go to the docs.scaffoldeth.io. If you want to learn more about building on Ethereum, go to speedrunethereum.com or go to the Scaffold ETH repo and start looking through the repos and see what different kind of builds there are. And yeah, start thinking about ways that you can interact with the blockchain in an interesting way in a peer-to-peer economy. Yeah, I'm really excited to see what you guys build. If you build on Scaffold ETH, please just tag me in the Discord channel. My Discord username is ninjutsu. I'm happy to help you there as well, as long as I'm available. I'm going to be doing some travel, but I hope you guys found this useful, and I'll talk to you guys soon. Take care.
Nítido, nítido. Muchas gracias a Kevin, ¿verdad? Por esa participación, ¿verdad? Es un sacrificio que hizo por, ¿verdad? Nuestra comunidad, nuestra audiencia, nuestros developers, y espero que hayan aprendido algunas cositas, ¿verdad? Para implementar en sus proyectos. ¿Alguien tiene algún comentario, alguna duda? A ver si lo podemos aclarar, ¿verdad? Cristian está ahí buscando la documentación para, si acaso, ¿verdad? Revisar o discutir. ¿Alguien tiene algo que decir?
Déjame permitirles a ellos quitárselo, poder hablar. Ya ellos pueden hablar, sí. Nada, yo estoy aquí ahora mismo entrando a Scaffold ETH porque quería añadirle a lo que Kevin les presentó, que algo que está bien interesante de este proyecto es que pues él ahora mismo pues, en este video que él les acaba de grabar y compartir con ustedes, él estaba trabajando con el Master Branch. Y el Master Branch, pues lo que te trae son los features que él te estaba enseñando. Pero si ustedes ven aquí los diferentes branches que hay en este repositorio de Scaffold ETH, se van a dar cuenta que aquí hay cientos y cientos y cientos de branches. Y todos lo que te ofrecen son diferentes boilerplates o starting points de diferentes tipos de proyectos. Y si ustedes están tratando de, por ejemplo, hacer un proyecto de NFT, ustedes pueden escribir aquí NFT y se van a dar cuenta que mira, aquí por ejemplo, tienen una implementación ya comenzada de lo que es un NFT Gated Authentication System, de lo que es los NFT Royalties, de lo que es Aging NFTs. O sea, aquí hay muchísimos proyectos que ya están utilizando Scaffold ETH como el punto principal y ellos le construyen código adicional que luego ellos comparten con este proyecto y lo crean como un branch nuevo para que otras personas puedan utilizar estos boilerplates, estos proyectos ya comenzados, que ya están configurados, para que las personas los puedan utilizar. Y está bien interesante porque, mira, por ejemplo, aquí tenemos hasta ZK Sync, que son proyectos de básicamente que son deploy a otros testers y todas estas cosas. O sea, aquí podemos encontrar muchísimos proyectos de diferentes maneras. Aquí tenemos un DAO Memory Pool, o sea, ustedes pueden buscar aquí muchas de las implementaciones que ustedes van a hacer en el hackathon. Pueden encontrar aquí código que ya está comenzado y que ya está configurado. Por ejemplo, no sé si se dieron cuenta, él hizo el deployment a Gorley. Muchos de estos proyectos ya, todo el script que ustedes necesitan configurar para hacer deployment a diferentes pues, networks, ya estos proyectos los traen. Y por eso es que lo queremos traer a la colación, porque pues básicamente lo que Scaffold ETH le provee a los developers es una manera de usted desarrollar de una manera rápida y testear las cosas de una manera sencilla sin que usted pierda mucho tiempo testeando una idea o confirmando si algo funciona o no. Así que nada, si alguien tiene preguntas, yo las puedo cubrir ahora. Las pueden escribir en el chat o se pueden desmutear y pueden hablar. Y si no, pues nada, lo podemos dejar aquí. Ya vamos para una hora, así que nada, ustedes me dejan saber. Voy a estar aquí 5 minutitos más esperándolos por ustedes. Así que nada, ¿alguien tiene preguntas? A ver el chat. Si nadie tiene preguntas, pues nada, como Kevin dijo, Kevin va a estar en el Discord. Si quieren hacerle alguna pregunta referente a cómo usar Scaffold ETH o cómo configurar Scaffold ETH para su proyecto, le pueden escribir, lo pueden taggar, él va a estar en el Discord. O si no, me pueden preguntar a mí o le pueden preguntar a Edgar y nosotros pues con mucho gusto vamos a ayudarlos. Así que nada, este, ¿no hay preguntas? ¿Todo el mundo bien?
Pero yo tengo una pregunta.
Sí,
Este,
cuéntame.
¿Hay algún tipo, verdad, de versión ¿verdad? De versión de los branches que recomiende, sabes, ¿verdad? Yo sé que lo estás viendo ahora, ¿verdad? Pero que recomiende dependiendo de los challenges, porque hay, ¿entiendes por dónde voy?
Sí, entiendo la pregunta. Si hay algún branch aquí específico que esté relacionado con los challenges del hackathon. Pues mira, no directamente con los challenges del hackathon, porque obviamente como estos son boilerplates bastante general, no vas a encontrar una solución completa para lo del hackathon, pero sí vas a encontrar muchos detallitos. Por ejemplo, no sé si, mira, aquí tienes una multisig. Si quieres implementar una multisig en tu proyecto, aquí puedes encontrar una implementación que te permite pues, ver cómo se implementa una multisig diferente. De igual manera, ahorita él en la presentación, si no me equivoco, en un momento él subió un QR code de Speedrun, creo que era Speedrun Ethereum, era.
Speedrunethereum.com. Que ahí hay una
Entonces,
serie de...
si hay una implementación de una multisig, ¿qué diferencia tendría esa implementación a Gnosis Safe, que es una, ¿verdad?
Básicamente es la customización. O sea, si tú usas Noxys Safe, lo puedes usar y eso está magnífico porque eso ya es un solution out of the box. Pero tú tienes, si usas, por ejemplo, ese sistema que ya está implementado, tú tienes que adherirte a la implementación que ellos tienen. Versus, mira, por ejemplo, aquí esto está locked ahora mismo, pero esta página que él tiene te tiene diferentes challenges. Mira, aquí hacen un NFT, hacen un Decentralized Staking App. Aquí tú haces tu multisig, aquí te está pidiendo que implementes un multisig y la diferencia es que cuando tú haces tu propio multisig smart contract, tú puedes literalmente hacer lo que tú quieras. O sea, tú puedes definir la implementación completa de esa multisig versus la de Gnosis Safe, que tienes que adherirte a lo que ellos implementaron porque no puedes customizar ese smart contract. Si tú haces tu propio smart contract con tu propia multisig, tú puedes definir todas las instrucciones, todas las reglas, cómo es la votación, qué se hace con esa votación. O sea, literalmente tú puedes customizar tu contrato al 100%. Con Gnosis Safe, pues no vas a poder hacer eso. Tienes que adherirte a las reglas que ellos implementan.
Ok, ok, gracias, gracias.
Ok. ¿Alguien más tiene preguntas?
Otra cosa,
Sí.
ese Speedrun Ethereum,
Esto
cuando
es como... Ajá.
es
Sí.
como un free code camp prácticamente, o
Sí,
literalmente un challenge.
teóricamente es como un free code camp donde ellos te ponen challenges para que tú practiques y aprendas a utilizar las tecnologías de Ethereum. Lo que pasa es que este lo corre Kevin. ¿Me
Ok.
entiendes? Que Kevin parece que está comenzando este nuevo non-profit. Y sí, se ve que básicamente
No,
tú
no, se
coges los
ve bueno,
quests.
¿verdad?
Sí, sí, y entonces no sé cuáles son los premios, cuáles son pues, los awards que recibes por el challenge, pues, después que completes el challenge. Pero te pide que conectes el wallet. No sé si te dan un coin, de verdad no sé cuál es el reward system que tienen, pero se ve bien interesante. En verdad, a mí me gustaría, después cuando tenga tiempo, ir y hacerlos todos para mantenerme activo codeando, que eso es algo que muchas veces, pues, uno cuando está bastante tiempo sin codear, pues uno se pone rusty. Y
El
estos son más,
ID, el ID está integrado ahí como los de free code camp que tú sepas, es que literalmente no nunca he entrado ahí.
pues, de verdad que no sé. Te puedo verificar aquí mismo, no sé cómo es el submit, cómo se hace el submit. El submit me harás por MetaMask. So, asumo que yo tampoco había visto esta página, hoy por primera vez que la veo cuando Kevin la mencionó. Pero asumo que tienes que hacer un deployment. Y entonces ellos te van a generar, por ejemplo, unos NFTs. Y esos NFTs, somehow, lo que tienes que poner es el address. So, asumo que él tiene alguna manera de verificar una vez ya hagas el deployment, pues, que hiciste el challenge y que los NFTs están en tu wallet. Pero se ve interesante. Después con calma me puedo sentar a ver cómo funciona todo el challenge. Y mira, aquí tienes hasta el código en GitHub y todo. Pero sí, se ve interesante. Mira, ve, esto es, mira, Challenge 0, Simple NFT.
Ok.
Y mira, aquí tienes el Challenge 5, el Multisig. Aquí puede ser que encuentres la implementación del smart contract del multisig por si de alguna razón quieres implementarlo from scratch, pues lo puedes buscar por aquí. Hard hat, vas a contracts, your contract ahora mismo debe estar en 0, pero ajá, se supone que el goal es que obviamente lo implementes tú. ¿Tenemos más preguntas? Anyway, todos, gracias por conectarse. Si tienen preguntas o dudas, por favor pónganlas por el Discord. Estamos viendo quiénes están usando el Discord y quiénes no. Es importante que usen el Discord para que los otros mentores estén al día y estén al tanto de lo que están haciendo. Entonces, creo que Luis Obregón, creo que me habías puesto algo en el Discord. Voy a verificar el documento que me subiste ahora y te doy mi feedback lo más pronto posible. Así que nada, gracias a todos por conectarse. Y nada, nos mantenemos en contacto. En verdad, ya estoy ansioso de ver lo que están trabajando y que vayan el 4 de diciembre y hagan unas presentaciones de sus proyectos. Y pues, y ojalá y se lleven los premios y todos los jueces queden impresionados con lo que ustedes están trabajando.
Quiero, quiero añadir nuevamente gracias, ¿verdad? Por conectarse. Estos videos y grabaciones se van a estar compartiendo por YouTube. Los links se tiran por el Discord próximamente. El de Chainlink que se dio la vez pasada, ¿verdad? Con Pedro Cruz. Y ahora el de Scaffold y los futuros también. Así que nada, para que estén pendientes. Muchas gracias.